My name is Kat Kennedy, and for our project, we will be lighting up a Lego car. This will be an interesting and relevant project because these are circuits we've used in class and in our everyday lives. Doing this would allow us to do something we can directly relate to the world and will give us a better understanding of how lighting system and real cars work. Plus, everyone loves a good Lego car, so an enhanced one would be even more fun. This project is actually going to have three different circuits that will be working together as one system. Here's figure 1 down here that shows the circuit diagram for the automatic headlight system. The circuit works because it automatically turns on vehicles' headlights when the light falls below a certain threshold. The LDR and variable resistor form a voltage divider that changes the input voltage to the 555 timer depending on light intensity. When it becomes dark, the voltage on the 555 timer input triggers its output high, which turns on the BC547 transistor, which energizes the relay coil. The relay connects the power to the headlight bulb, which turns it on automatically. When light comes back, the LDR's resistance decreases, the relay deactivates, and the headlights turn off. One main component here is the LDR, or light-dependent resistor. This essentially acts as a light sensor that detects the surrounding brightness level, and we've used these in class a few times as well. Another main component is the 555 timer, which is configured as a comparator monostable switch that controls when the relay activates based on the input voltage from the LDR. And a third component is the relay module, which is driven by the BC547 transistor, and this just switches the headlight circuit on or off depending on the 555 timer output. Figure 2 here shows the circuit diagram for turn signal lights and is able to work because when it's powered with 12 volts and the turn signal switch is engaged, the 555 timer begins to generate a square wave pulse at a frequency set by resistors R1, R2, and capacitor C1. These pulses are fed into the CD4017 decade counter, which advances one output pin high with each clock pulse. As the outputs change, each transistor and LED pair turn on sequentially, which creates the turn signal effect. Adjusting the RC timing changes the blinking speed, and one main component is the 555 timer, which is configured as an astable multivibrator that produces a continuous clock pulse to control the sequencing speed. Another main component is the CD4017 decade counter, which receives the pulses from the 555 timer and sequentially drives the output pins to activate each LED one after another. A third component is the BC547 transistor with LEDs, where each transistor amplifies the control signal from the CD4017 to power its corresponding LED segment in the turn signal chain.
Figure 3 here shows the circuit diagram for a brake light flasher. This circuit works because when the brake switch is pressed, 12 volts of power is applied to the circuit, which activates both the 4024 counter and the 555 timer. The 555 timer generates pulses that cause the transistors to switch the brake lights on and off rapidly for a short time, creating a flashing effect. After a few flashes, which is determined by the 4024 counter, the lights will remain steadily on, just like normal brake lights. One main component is the 4024 binary counter and divider, which divides the input signal and determines how long the brake lights will flash before staying steady. Another main component is the 555 timer, which is configured as an astable multivibrator that generates the flashing pulses for the brake light sequence. A third main component are the transistors, which work together to amplify the signal from the 555 timer and drive the higher current brake lights. To do this, we will wire all three of the circuits, solder them into a perf board, then attach it to the bottom of a Lego car. We will then drill through some of the Lego pieces and wire buttons or switches into the driver's area of the car to make the controls accessible to the little driver. We will make sure that everything is attached that way. That way the headlights will light up as LEDs in the actual headlight part of the car. The turn signals will light up in the actual headlights and taillights using LEDs, and the flashing brake lights will also light up in the actual taillight using LEDs. Essentially, it will be displayed as a normal car in Lego form. A lot of the challenges we expect to see while constructing this have to do with the modifications we will be making to our circuit. We plan to combine these circuits, which will be challenging to put them all together while maintaining the individual functions. We also plan to alter the turn signals to be running turn signals instead of regular ones. Additionally, we are going to change the flashing brake lights to regular brake lights. These will bring about a lot of challenges as it will require us to branch out and use only our minds rather than following a circuit diagram. Also, getting the circuit wired nicely into the car will be a challenge because it will be a large amount of wiring that has to be attached to a pretty small car while remaining fully functional.